Hey, hi, and welcome back. So now we are just left with few connections and let's complete those connections in this video. Alright, so now let's start with this video. Now we are left with some, air wires, okay? And we are not sure where those air wires are. So what you have to do, you have to go to the errors and you will see multiple air wires here. So you have to click on them and you have to find out which are those air wires, and accordingly you have to do the connection. Alright, so here we have not connected the track from this point to this point. Alright, so let me do the connection here and I will do the connection. First of all, let's quickly do the connection, and you can see those air wires are actually disappearing from here. And if I click on rat nest, then you can see automatically that plane will disappear and there will not be any kind of short circuit here. Okay, so now let's go to the another air wire. So there is a connection from this point to this point. So let's think about this connection later. Let's go to the another air wire, and this is actually the 5-volt connection which we have not connected. So let's do this connection now, and let me connect. First of all, you have to check where this 5-volt signal is going. So let's split the screen and let's check. So this is basically a pull-up resistor. Let me verify. So yeah, this is actually a pull-up resistor. It's not highlighted. Why? Alright, so it's highlighted now. So this is basically a pull-up resistor, and again this is again a pull-up resistor, and the current which is going to flow through this pull-up resistor towards this, their respective pin, it's going to be very less. So again, a trace width of 10 mil is actually enough to do the connection. So I'm just going to change the grid option to 10 mil, and later I will do the connection, and angle will be this one. So let's do the connection quickly, and let me connect it here like this, and after that I will click on rat nest. Now so we are left with this connection now. First of all, let's go to the warning option once again, and let's see which air wires are remained. So this one is there, then this one is there, and then this one is there. Okay, so it's saying that this is not connected. So you just rip up this connection and connect it once again, and we selected the trace width here as 25 mil. And let's connect them properly like this. Okay, so we just have 2 air wires now, and these air wires are actually because of because there is no path for this plane. If you see, this is actually a ground plane. Okay, this entire shape is a ground plane, but this plane is not connected to the ground. Okay, so what you can do in this case, you can actually give a via here. So once you give a via, and if you click on rat nest, then this particular via is actually creating clearance around it, because there is no naming to this particular via. So we are going to give the name here, and we will write here GND, and after that we will click on OK. Now this particular via is actually a ground via, and this plane is now connecting to the ground plane on the bottom layer with the help of this via. That's the reason there is no air wire here. Okay, so if you see, if I click on this one, that issue is now resolved. So I will just click on warning once again. Okay, so still it's showing that. So I'm just going to click on rat nest. Now you can see that warning or that particular error is now disappeared. All right, but you make sure that when you are providing the via, you are providing the via in enough amount, because the current is actually going to flow from this plane, okay, on the bottom plane, okay, which is also the ground plane. So this is actually a capacitor, and this one is for this switch, user input switch. So the current which is going to pass through this capacitor, it will not be too much. So one single wire is actually more than enough here. Okay, now we are just left with 1 air wire, and again this issue will be resolved if you provide this plane that you see, this entire plane is actually a ground plane, but this plane is not connected anywhere to the ground on this layout editor. That's why it's showing that there is no connection between this ground and this ground here. So what you can do, again you can do the same thing. So I will just copy this ground here, a ground wire here. So I will just copy this one and later I will place it here. Now this plane which is on top layer in red color, it's actually connected to the bottom layer. Okay, ground plane on the bottom layer. And if I click on rat nest now, okay, still it's not resolving, means this air wire is actually not disappearing. So what we will do, we will give one more wire, and let's not give here. Let me copy the wire. Alright, so I have copied the wire. Okay, and okay, so this yellow warning is there because there are multiple wires on the, one top of each other. So I will just copy this one and later I will place this wire here, and still it's not resolving the issue. So if I click on rat nest, alright, so let's try to connect this plane. Okay, I think let's try to connect this plane on the bottom layer. So again I will just copy this wire and I will place this wire here, and you can see now that connection is disappeared. So what exactly that mean? I will tell you the reason why that happened. We tried to connect this plane to the ground plane, okay, and it also connected on the bottom layer. But this plane that you see, this entire plane was completely isolated and it was not connected to the ground anywhere. That's the reason when I place a wire here, it's now connected to the ground. But single wire is actually enough in this application, but I will recommend you to place multiple wires like this, and you can actually connect in a proper manner, in a design also we can say, which I have placed on our layout. When I will provide you with the final layout editor file, there you will get to know. So likewise you can place multiple wires on the, this will actually resolve the issue related to return path or return current path, and it's going to give a straight path for the towards the ground. So for example, I will tell you now, let's consider this capacitor. Okay, let's consider that if the current flows through this capacitor, okay, then it's going to follow this path, okay, through this plane. Then from here it will go to the bottom layer. So let's go to the bottom layer. Okay, let's try to understand this in detail. So it will go to the bottom layer, but the final destination of the return current is actually here, but there is no path in between. So what the return current will do, it will go like this, then it's going to find the shortest path and it will go like this. Okay, so when you provide wires, multiple wires, they are actually going to give the shortest path to the return current of the respective section. So for example, for this particular IC, let's try to understand. For this particular IC, there is a 5 volt here, okay, and then there is a ground here, all right, and then the current is going to it will flow like this. Okay, let's try to find out the shortest path for this particular IC. So shortest return current path, it will not be, so you can see here there is actually a blockage. So this return current is actually going to look for the shortest current path like this, and then it's going to travel towards this point. Whereas if you could have provided a wire at this point, so let's try to provide the wire here. If I provide wire here, so the current is actually going to flow like this at this point. Then from the bottom layer, let's go to the bottom layer. From here, it can actually choose the shortest return path. Okay, so with this wire, what happened? We actually provided the shortest path, a return current path to this particular IC. So that's how, if you place multiple wires on your PCB everywhere, okay, try to place it in a right manner. Okay, it should not be like you are placing too much wires on the PCB. So with this wire, we have provided the shortest return current path for this particular IC. Otherwise, the return current for this IC would be like this. Okay, it would have passed, it would have went like this and then towards this point. Now the current is directly going towards okay, it's actually following this path. Okay, so always remember, when you create the layout, you also have to think about the return current path for that particular section. So we discussed for this one, we discussed for this IC. Let's try to understand for this IC. So there is actually a straight path for, for this IC, the path is very straightforward because the connections are on bottom layer. So let's go to the bottom layer. So here, from here, the 5 volt is coming towards this IC, and then the return current path for this IC is going to be like this. Okay. So straight away from here, it will be towards this point. But now you will see that from here, the current is actually not going towards this final destination because it's on top layer, right? So so here I have to provide a wire. Okay. So if I provide wire here, so the current will flow like this, then it will go to the top layer here, and then it will reach to the final destination. Okay. So that's the reason we need to provide multiple wires on our entire PCB, and then these kind of issues, it will automatically get resolved. So you just provide the multiple wires on the PCB, and that will actually, provide the shortest current path to all the components which are present on the hardware. Alright. So I hope that every single thing that we discussed in this video is now clear to you. Now I will see you in the next video.